All right, guys, so this video is going to cover notes 8.1, going over similar right triangles, and what you'll realize is we're pretty much doing geometric mean for these types of problems. So to start off the notes, we just want to recall some important pieces of information here. First, we want to look at the anatomy of a right triangle, right? So understanding that the hypotenuse is always located across the 90-degree angle, right? So that's super important. So your hypotenuse is across the 90, and the other two sides of your right triangle represent your legs, right, which are here in blue. Now, next, we want to go over something known as the triangle angle sum corollary, right? So what a corollary is essentially a direct result from a theorem. So our triangle angle sum theorem that says all three angles in a triangle add up to 180, well, a direct result of that, or a corollary of that, would be in a right triangle, right? Notice here that we got the right angle. Now, if I were to take away the right angle, the 90 degrees, from the total sum of all three angles, we're left with 90 degrees. So what that essentially tells us is that the acute angles here, angle A and angle B, would have to add up to 90 degrees, right? So I'm purposely marking these with 1 ring for angle A and 2 rings for angle B, because we're going to pretty much use this idea later on in the notes today. So we understand here that in any right triangle, the two acute angles would have to add up to 90 degrees. And then lastly, we just want to go over geometric mean one more time. Remember that geometric mean of two positive numbers a and b is the positive number of x that satisfies the following proportion, right? So this proportion right here, a over x is equal to x over b, right? And that's really the main proportion that we're looking at throughout the notes today, right? And your shortcut, whenever you're just asked simple geometric mean questions given two numbers, is really just using that formula x squared is equal to ab. But hold on to this idea right here, the actual proportion a over x is equal to x over b. We're going to see that pop up a couple of times here throughout the notes. So just diving straight into it, what we're going to look at here is the right triangle similarity theorem. So what this states essentially is that if the altitude is drawn to the hypotenuse of a right triangle, which our altitude is AC right here, remember altitudes are going from the vertex to the opposite side, creating a 90-degree angle. So that's our altitude. So if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle. Right, so the two triangles formed we have here are, let me actually outline them, right? So here's one here in red. So after drawing in that hypotenuse, I get this red triangle, and I also get this blue triangle directly next to it. What this is saying is anytime an altitude is drawn to the hypotenuse, then what we basically get is three similar right triangles, denoted by the similarity statement below. Triangle ABD is similar to triangle CBA, which is similar to triangle CAD. Now, that may not be immediately obvious, so let me actually go ahead and show you and prove to you why these triangles are similar. So let's take that same exact picture, and what we're going to do is, to start off, we're going to mark one of the acute complementary angles in the large triangle with 1 ring, and the second angle with 2 rings, kind of like what we did at the beginning when we were doing that little recall section. So what I'm going to do here is I'm going to label this triangle angle with angle D here. I'm going to label that with 1 ring. Actually, let me do that in a different color. Let me actually do that in black so it's easier to see. So we're going to label that with 1 ring, and angle B will be labeled with 2 rings, right? So what we're going to do now is we're going to separate out all three triangles, right? Because this is really messy to look at when they're all kind of inserted inside of each other. So let's look at the large triangle here, which is triangle DAB, where the right angle is located at angle A, right? So the way that we marked this just now was that angle D had 1 ring and angle B had 2 rings. Next, let's draw the red triangle. So our red triangle here would be triangle DCA, with angle C having the right angle, right? And we're noticing here, well, this red triangle also contains angle D, which happens to have 1 ring. And then lastly, we'll take a look at the blue triangle at the very right, which would be triangle, so clean this up here, CAB, with C being our right angle here. And angle B happens to be shared between that blue triangle and the large triangle in black DAB. So what we see here is 3 triangles, right? And this is how we're going to note that these triangles are similar, right? So one of the theorems that we looked at in chapter 7 was that we can prove that 2 triangles are similar by angle, right? So if you take a look here, what you'll end up noticing is that, well, when it comes to the black triangle and the red triangle, they both have a right angle, so that takes care of one angle pair. And they also happen to have a second pair of congruent angles, which would be the one with one ring, right? So these are congruent by angle, angle, right? Same could be said here for the black triangle and the blue one, right? So for the black triangle and the blue one, then we see here that, well, yeah, it's got the right angle. That's one pair. You do this in blue here. And it's got the second pair here with the two rings, right? So denoted by those two, right? So what we see here is that these triangles are similar by angle, angle, right? And so the way that this kind of works is we can almost kind of use the transitive property here, right? So if the red triangle is similar to the black triangle, and the black triangle is similar to the blue triangle, then we can assume here that the red and blue triangle must also be similar, right? So just to kind of prove it here, these three triangles are similar by angle, angle, right? So now the utilization of these rings will allow us to kind of write a similarity statement. So now that we understand that these triangles are similar, it's also understood from chapter 7 that angles of similar triangles, those corresponding angles are congruent, right? So we already know that these triangles are all similar to each other. So it can be filled out to say that the corresponding angles here would have to be congruent, right? So in other words here, that this would have to have two rings. And in the blue triangle, this would have to have one ring, right? To be able to say that all three of those angle pairs are congruent. So if I want to write a similarity statement here, this is where it's coming from, right? So they started off with triangle ABD, right? So triangle ABD. So starting with the right triangle, not the right triangle, the right angle, sorry, they are all right triangles. But starting with the right angle, that's A. Next we have the angle B, which is two rings. So that would be similar to starting off the same, right triangle and then two rings, or right angle and then two rings. So CAD for the second triangle. And for the third triangle, we're looking at starting the same way. We started with the right angle, and we started with then the two rings. So this would be CBA. So that would be how we write the similarity statement. So this part, while we're looking at the beginning of the notes, is actually extremely important because this could be a potential question that we ask you guys on a quiz, right? So being able to take apart all three triangles and write a similarity statement between all three is extremely important. I think the easiest way of doing that is by using those rings in the very beginning, all right? So let's actually go ahead and go over a few reminders, which we kind of discussed just a moment ago. Remember that anytime an altitude is drawn to the hypotenuse of a right triangle, it will produce three similar right triangles, which is the theorem that we just looked at. So anytime you got an altitude drawn to the hypotenuse of a right triangle, it's going to produce three similar right triangles. And we also need to recall that similar triangles have corresponding angles that are congruent, like we just mentioned a little while ago. And it's also noted that corresponding sides of similar triangles are proportional, right? And we use these proportions to solve for missing sides from chapter 7. We're pretty much doing the same thing here, except I'm not just looking at two triangles. Now I'm looking at a total of three triangles. So let's take a look at example 1 and see kind of what this is going to look like, right? So my first piece of advice here would be to identify where all three triangles are. So the large triangle, PSR, and I'm going to leave that just in black. The second triangle we have here is going to be here in red, which will be highlighted there. And then we have the blue triangle here outlined in blue. So we got our three triangles here. And so to start these types of problems off, if you're going to treat these as similar right triangles, then you're going to want to start off from the very beginning by labeling the two acute angles in the biggest triangle. So my acute angles in the large triangle as a whole would be angle P and angle R. I'm going to label that with one ring for angle P and two rings for angle R. And now we can go ahead and start separating out those triangles. So if I look at the large triangle as a whole, here's my large triangle. This will be triangle PSR, where S contains the right angle, R contains the two rings, and P contains the single ring. Next, we have the red triangle, which in this case here will be triangle PQS. And we see that angle P is the one that contains the one ring. And then lastly, we have the blue triangle. Gosh, that was an awful triangle, but we're going to run with it. It doesn't have to be perfect. So here we see that this is triangle QRS, and the R has the double rings, right? And so the idea here now is going to be this, right? I've got my rings filled out here. We already know that these triangles are all similar, so all of the corresponding angles must be congruent, right? So I'm going to need to have essentially a set of double rings in the red triangle, so that can only be located here for angle S. I'm going to need in the blue triangle the single ring, so it's going to be located on S for the blue one. So we've got everything pretty much set up here as far as the angles are concerned. Let's go ahead and start labeling the sides that we know for this triangle. So to start, what I can see here is that in the large triangle, and let me do this in a different color so it's easier to read. In the large triangle, we see that from P to R is broken up into two pieces from that altitude, 12 and 2. So adding those together, this hypotenuse would be 14. And then also in the large triangle, I see that SR is labeled as X. Moving on to the red triangle. In the red triangle, what we currently know is that PQ is 12. I don't see that any other side has been labeled or that we have enough information to find any other side in the red triangle. So we move on to the blue one. The blue one has this bottom side QR labeled as 2 and the hypotenuse labeled as X, right? So the idea here is this. If you got highlighters, right, if you're looking at taking your notes on class notebook or on the PDF, go ahead and use 3 different colors here. This is just going to help us kind of see and make some connections on how we write our proportion, right? What I want you to do is I want you to highlight all of your sides, your short legs in yellow, right? And you'll notice that here, it's going to be the side that contains the right angle and the double rings. Right angle and double rings, right angle and double rings here. So all of those sides would be corresponding to one another. Now let's do the same thing, but now let's do it to the long leg, right? So the long leg here would be P to S, which would be single ring to right angle, single ring to right angle, single ring to right angle. So those are my corresponding long legs. And then lastly, we're going to look at our corresponding hypotenuse. So my hypotenuse here in pink, hypotenuse here in pink, hypotenuse here in pink. So the idea here essentially is going to be this. I want to set up a proportion to solve for X. So the way that I usually like to set up these proportions is going to be the following way. I like to set these up as short leg over short leg would be equal to long leg over long leg would be equal to hypotenuse over hypotenuse, right? Depending on, the information that's provided, right? So if I take a look at my triangles, if I want to set up a proportion and solve for X, I need to know 2 sides of the triangle minimum, right? The only triangle that I don't know the 2 sides of is the one in the middle, the red one. So this is kind of suggesting that we have to use the first triangle, the one in black, PSR, and the last triangle in blue, QRS, right? We have to use those 2 triangles to set up our proportion, right? So what I can see here is if I want to set up my proportion, what I'm going to be setting up here is, well, I know yellow corresponds to yellow, so I know that pink corresponds to pink, right? I'm just going to decide to start with the pink. Let's start with the hypotenuse, right? So I can say that 14, that pink hypotenuse of the first triangle would correspond to the pink hypotenuse of the last triangle, which would be X. So I can write a ratio of 14 over X. That would be equal to, well, now let's look at the other side that we know or have labeled in the first triangle, the yellow side, the short leg. The short leg here would be X over the short leg of the last triangle, which would be 2, right? So again, to reiterate here, the way that we set this up, the 14 over X was basically us doing hypotenuse over hypotenuse, and the X over 2 was us doing the short leg over the short leg. And you'll notice that I'm putting SL for short leg. Anytime you see me put SL, I'm basically saying short leg. LL would represent long leg. So what we can do now is we can cross multiply and solve for X. One thing that I do want you guys to understand here is once you set up your proportion, you should see a diagonal that repeats, right? In this case, my diagonal that repeats is right here. It's X, right? If you got a diagonal that repeats, you're good. That means you set it up correctly. So we got X times X, that's going to give us X squared. If I multiply the other diagonal, then we're looking at 14 times 2, which is 28. Now, if I want to solve for X, all you have to do now is square root. So we get X is equal to, well, 28 can be broken up into 4 times 7. So I got root 4 times root 7, and I know that the square root of 4 is 2, right? So I'm going to write 2 square root of 7. And if you have me as your teacher, you know that I've given you guys a really hard time about taking the square root of something and making sure to put plus or minus, right? The reason why I'm not including the plus or minus here is because my x value can't be negative, right? X is labeled as the length of side SR, right? If it's labeled as that side length, I cannot have a negative side length. That's the reason why I'm only choosing to put the positive solution here. But our answer here would essentially be x is equal to 2 times the square root of 7. So to recap, your steps that I would suggest that you guys follow for doing problems like this is start with the big triangle, label your acute angles, one with 1 ring, this other one with 2 rings, and then separate out all 3 triangles. From there, highlighting is super helpful to see what corresponds to what and set up your proportions and solve for x, okay? So let's try that by looking at some other examples here, okay? This section of the notes, I'm going to come back to this, okay? What I do want to kind of get you guys used to is let me teach you one method, get you guys to practice that and be comfortable with it, and then I'll show you guys an alternative method that you guys can use. So let's try to look at the next one. Example 2, it says find QS, right? So currently, I don't know the value of QS. So what I'm going to do here is I'm going to label QS as X. We don't know what QS is, right? So this is just X. So in the spirit of following the same steps that we did earlier, let's go ahead and do the same thing, right? So let's go ahead and start off by looking at the big triangle and labeling our acute angles, right? So my large triangle, triangle PQR, has acute angles of P, which I'm going to mark P with 1 ring, and I'm going to mark R with 2 rings. So from here, identify your 3 triangles. I have the one in black, right? So the large one, which I might as well just draw out now. This is triangle PQS, with Q having the right angle, P with a single ring, S with double rings. Next, we have the triangle here that I'm going to outline here in red. This will be triangle PSQ, where angle P has the single ring. And then the triangle here in blue, which is the one to the right here. Drawing that out, will be triangle SQR, where R has the double rings. So going ahead and filling out the rest of the rings that we're missing here, we know that these triangles are similar. We've established that anytime an altitude is drawn into the hypotenuse of a right triangle. So that would imply that the corresponding angles have to be congruent, right? I got the single ring taken care of in the red triangle. That means that Q has got to be the double ring. In the blue triangle, I've got the double ring taken care of. That means for the blue triangle, Q would be my single ring. So now let's go ahead and label the side lengths that were provided to us, right? So what we currently know right now is that I wrote that wrong. Sorry about that, guys. The black triangle is PQR. I'm not sure why I wrote the letter S. This should say PQR. My mistake. So from P to R, they told us that the hypotenuse was 30, right? And we also know that for the hypotenuse, well, that's pretty much it. Not the hypotenuse, I'm sorry, the large triangle in black, all I know is that hypotenuse. That's it. So moving on to the red triangle. They did tell us that PS, that bottom side is 6. And the altitude is what we're looking for, which we labeled as X. So I'm going to label that as X. And in the blue triangle, we also have the altitude in that one, QS. We labeled that as X. Now, SR isn't directly labeled for us, but we have enough information to find it, right? 30 minus 6 would tell us that SR is 24. So looking at what we have currently, again, the highlighters help just do this a lot easier as far as, corresponding pieces are concerned. I see here that from P to Q, that's my single ring to right angle. So corresponds single to right angle, single to right angle. Then I take a look at my right angle to double rings, right angle to double ring, right angle to double ring. And then lastly, our hypotenuse. So now that we have everything set up, everything labeled, everything color-coded, remember that this is kind of the basis on how we're setting up our proportions, right? Short leg over short leg, long leg over long leg, hypotenuse over hypotenuse. So looking at the 2 triangles that we have, again, like I mentioned in the last example, is you have to know at least 2 sides of a given triangle to be able to set up a proportion with another one, which would also need 2 sides, right? So that clearly tells us that I'm working with the middle triangle and the triangle at the very end on the right. So looking at how we can potentially set this up, and let's take a look at the following proportion, right? Let's say that I want to start with yellow, right? Yellow would represent the short leg, right? looking at the red triangle, I'm not an artist here. My triangle doesn't look perfect, but look at the picture here, right? Hopefully you guys can identify here that PS, that side length of 6, would be our short leg. So what I'm doing here is short leg over short leg. So looking at that triangle, we're looking at 6 over, well, what is the short leg of the blue triangle? Well, the short leg there is X. Now that's going to be equal to, I've already knocked out the 6 in the middle triangle in red. The other side length that I'm looking at is in green, which is going to be telling me that I'm looking at long leg over long leg for my second ratio. So long leg over long leg would be X over 24. And like I mentioned before, if you get a diagonal that repeats, that's an indicator that you set this up correctly, right? My diagonal repeats. What I can do now is we can cross multiply and start solving for X, right? If we cross multiply here, X times X is going to give us X squared. So we get X squared. And then 6 times 24 would give us 144. From here, if I want to solve for X, we square root. And we get the square root of 144. Well, that's just 12. Technically, it's, positive 12 and negative 12. But again, if I'm looking at QS is the length of a side. It can't be negative. So if X is 12 and we labeled QS as X, then we can say, hey, find QS. QS is going to be equal to 12. And so that's the idea here. Again, you're pretty much doing the same thing you did in chapter 7. Now we're just taking it one step further by not just having you look at 2 triangles. Now you're looking at 3, right? So let's practice with example 3, and then we'll look at these shortcuts that we skipped above earlier. So example 3 says find the value of X, Y, and Z. These are the more challenging ones because we have a lot of unknown values here, right? So going through our steps again, right? Step 1, you're going to want to label the acute angles of your large triangle with 1 ring and then 2 rings. So let's go ahead and do that. So we're going to label... Let's do angle G with 1 ring, angle K with 2 rings. So when I separate this out now, I'm going to do the large triangle. And one thing I do want to note here, this is triangle GHK. Some people like to rotate the triangles when they separate them out. I try to stay away from doing that because sometimes I've seen people make some careless mistakes by just rotating and potentially mislabeling. So I would suggest just don't rotate them, draw them as they look. So we got the black triangle. Here's going to be our red triangle here that we're going to draw. Our red triangle looks something like this, where we got triangle G. You'll notice that the right angle is missing a letter. Let's call that guy L. So G, L, H, right? If it's missing a letter or doesn't have any letters at all, you're more than welcome to label them with whatever letters that you like if it helps, which for me, I like to do that. And let's go ahead and label the rings, right? So G has the 1 ring, and I missed it in the black triangle, but G is 1 ring, K is double. If I look at the blue triangle, right, following the same color scheme that we've been working with before, let me go ahead and just outline this in blue here. This would be my blue triangle. It would look something like this, where we have L, K, H, and my double ring is located at K. So filling out the remaining rings, I mean, my single ring is at H here for the blue triangle, and for the red triangle, H has the double rings. So we got our triangles. Let's go ahead and label the given information that we have and begin to solve. So if I look at GH is labeled as Z in the big triangle. HK is represented by Y, and then the entire hypotenuse from G to K, they broke it up into 2 pieces, but adding them together gives us the length of 12. In the red triangle, they tell us that from G to L, when I do this, I like to actually look at the letters to make sure that I don't make a silly mistake. G to L is X, G to H is Z, and L to H is X. In the blue triangle, L to H, again, is X, L to K is 3, and K to H is Y, right? So we got everything set up and labeled. Again, the highlighting, it's there to help. Single ring to right angle is in yellow, single ring to right angle, single ring to right angle, right? Different color here. Let's do double ring to right angle, double ring to right angle, double ring to right angle. And then lastly, my hypotenuse to hypotenuse, hypotenuse. So we got all of our corresponding sides set up here, and we got a mess of numbers that we're looking at, right? The thing about this is you just have to start somewhere, right? Sometimes this takes a little bit of trial and error, but let's go ahead and start. I'm just going to write this at the top again because this is really the basis on how we set up our proportions. So let's take a look. Realistically, we need to solve for one of these variables, right? So If I wanted to solve for a variable, it's totally up to you. You pick whichever one you want to start with. The first variable that I see that at least is pointing directly at me is z, right? So if I wanted to do a proportion with z, then I would be doing z of the big triangle, right? Which I'm looking here at this z. So that's in yellow, right? That would correspond to yellow in all my other triangles, right? So I would preferably like to set that up with, my options here to write the first ratio would be z. It's either going to be z over this yellow 9 or z over this yellow x. Well, if I input x there, it's going to just complicate things. So probably best to go with the 9 here. So we got z over 9. That's equal to, and if I look at my other options here, in the first triangle in black here, so this triangle right here, probably not a good idea to throw y into the mix here. So let's pick the hypotenuse here. Let's do 12, my pink, over. I got to use the same triangle that had the 9, so I'm using these two right now. So this would be pink over pink. My hypotenuse over hypotenuse would be 12 over z, right? So just for reference on how I set this up, I basically did yellow over yellow is equal to pink over pink. Right, and so this is where the colors come in handy, or I'd like to think so. And again, before you proceed to cross multiply, double check, do you have a set of diagonals that repeats? And we do, right? My z repeats. So if I multiply, cross multiply, we're looking at z squared is equal to 9 times 12, right? Which 9 times 12 is 108. Now, if I want to solve for z, we square root. Right? This gives us z is equal to, well, the square root of 108 can be broken up into 36 times 3. So we got z is equal to root 36 times root 3. And that gives us, well, the square root of 36 is positive or negative 6, but we had the conversation already. My z value can't be negative because it's a length. So I'm just using the square root of 36, just the positive value, 6. So 6 root 3. So z is 6 square root of 3. And if you want to now, at this point, you don't have to do this in your notes. I would not suggest that you erase it. I would just fill this in kind of nearby. Well, let me practice what I preach here then. We're understanding that this z value, we found it, it's 6 root 3. Same thing here, 6 root 3. We're still left to find x and z. So if I want to find x, then what we're looking at is setting up another proportion, right? If I look at my options here, x is in the second triangle and then the third triangle. So absolutely no way that I'm going to be able to really set up a proportion with the first triangle to find x. I'm looking at the second and the third. So if I look at the second triangle, let's set up a proportion, right? X, I'm looking at the second triangle, so let's do green over green, right? If I do green over green, I'm looking at x over 3. That would be equal to, well, now I need another set of sides here. What are my options here? Do I want to do pink over pink? Well, if I did pink over pink, I'd be incorporating z. I now know z, so I technically could, but then pink over here is y, so probably not a good idea. Let's go ahead and go with yellow. So yellow over yellow would have us setting up the following ratio. Starting with the second triangle again, we would be doing 9 over yellow in the last triangle is x. Right? And then we got those repeated diagonals again, right? So green flag there, we're good to go. So x squared is equal to 27 when we cross multiply. Square rooting both sides, we get x is equal to root 27, which can be broken up into 9 times 3. And we're left with x is equal to 3 square root of 3. And then lastly, we just have to find y, right? So if I want to find y, I see y is in the first triangle and the last triangle. Right? So let's do this in a different color so it doesn't get difficult to read here. So if I want to find y, then why don't we start setting up a proportion with y? So looking at the first triangle, y is in the color green. So I'm going to set up a proportion here with green over green. So I'm going to do green over green. So y over the green one in the last triangle is 3. And then if I want to set up a second ratio here, I'm going to decide to go with the pink one because the y is pink in the last triangle. So let's do pink over pink. So pink over pink here would be 12 over y. We got those repeated diagonals, we're good. So moving forward, we get y squared is equal to 3 times 12 is 36. Well, if I square root that, we get y is equal to 6. And so there we have it. We got our values for X, Y, and Z, right? These problems, they do take a bit of time to do just because you're having to basically set up 3 different proportions and solve for 3 different variables, but the idea remains the same, right? So to summarize and recap, step 1, label your acute angles in the largest triangle with 1 ring and the other one with 2 rings. Separate out all 3 triangles, color code your corresponding sides, and begin to set up proportions to solve for the indicated variable. Right? And so to kind of look at the last bullet point here at the very bottom, just one final reminder, if you set up your proportions correctly, you should see a geometric mean where 1 diagonal repeats. All right? And so that's actually going to conclude this part of the video. All right? I'm going to record a second part of the video going through and showing you the way that these theorems here at the top work, the altitude theorem and the leg theorem. All right, but go ahead and work on the assignment. 8.1 here, we've got a number of examples for you guys to try, basically starting with number 5 on, the process of separating out these triangles and essentially finding the geometric mean of some of these lengths. All right, if you have any questions or found this video difficult to understand, please reach out to your teacher and schedule a time to come in for tutorial.